And we're going to continue straight away from the extended reality to something we talked about in the first day. And you also remember her. She's already smiling at me. She's super pumped. And from the first day, if you weren't there, I'm talking about Mary Hamilton, and she joined us for the panel discussion. And in the first day, it was more about business. Today, you see it's more about digital. And we talked about, well, we're all doing this great stuff. It's technology, digital, extended reality, we're coding. But we also have to drive it through our society, through our business, because we need the money, we need the mindset, we need the change. And there's also a lot of hurdles and challenges to keep that change and that innovation going. And she is back better than ever from that first day. And now she's going to dive a bit deeper. And she calls it Leaders Wanted, Masters of Change at a Moment of Truth. Meaning, and I'm not going to take away too much of her presentation, she'll probably explain it herself, but now is the moment of truth that we have to go further, and technology has more of an impact on nature, society, economics, and she's looking for those leaders. So if you are those leaders, let me know in the chat and enjoy the presentation of Mary. Mary Hamilton, take it away.
Thank you so much. It's great to be back. I'm going to share a little bit more related to my day-to-day, which, as the managing director of our technology innovation for the Americas, I look after all the really cool emerging technology from research all the way through to how we partner with startups, how we think about prototyping with these emerging technologies. So, I'm really excited to share with you today a sneak peek into the future. Hopefully, you'll hear some new technologies, expand your thinking. Hopefully all of you will walk away wanting to be leaders who are masters of change. So I want to start off just, as we're thinking about the future, it always helps to ground a little bit in where we've been, right? So I want to take a look at the adoption of major technology trends over the years, right? So, and we've been using this slide for a couple of years now. And I think it's a great representation that takes us through the history of amazing technology innovations from the 1950s, right, where Turing tests and mainframes, to maybe the late 80s and mid 90s with cloud and software as a service ramping up, to the convergence of emerging technologies like AI, XR. You heard some of that just now, blockchain, quantum computing. Right. And those are all accelerating into steeper and steeper take-up curves. And as you can see, we're really seeing an exponential rise of technology and a compression of those waves of tech, right? They're getting closer and closer together. And the pace of exponential technology is only increasing. And it means that organizations have to continue investing to stay ahead. And the laggers who maybe are a little behind, they have to start closing the gap now because the gap continues to widen. So we are now, probably over a year and a half into a global pandemic, and there's still a lot of uncertainties. But one thing is absolutely irrefutable. Technology has been the lifeline that has sustained us through the pandemic, and it's redefining our reality. It also pushed a giant fast forward button to the future. Most of the organizations that we've been working with, they have stepped up to use technology in just extraordinary, incredible ways to keep their businesses and their communities running. And they've done it at a pace that previously you would have thought to be impossible. And so I think, if we look at how people are applying technology in more powerful ways than ever, it's changing and shaping the way our lives are run, right? The way we live, the way we work, and our very society. So I thought I would give you a little look at perhaps what's coming next. So a lot of this is based on the research that we're doing in our labs. And one of our newest areas of research is around neuromorphic computing. It's computing hardware, algorithms, and software based on computational models of the brain. So if you think about traditional architectures, right, your logic unit and your memory unit are separated, and the data kind of shuttles between. Maybe not that efficient. If you think about device architecture from biological computers, your brain, the logic and the memory are closely integrated in essentially the same basic device, the neuron, right? And also in the connections between the neurons, the synapses. And it turns out that neuron-based circuits are particularly good at parallel processing, right? And that makes for good pattern matching and memory retrieval. The challenges are around, how do you replicate, the human's ability to be flexible, the ability to learn from unstructured stimuli, and the energy efficiency of the human brain. There is a new computational accelerator called Neuromorphic computing, and companies like Intel with their low heat chip are exploring this. And the reason it's relevant today is that some of these breakthroughs in the hardware and the algorithmic advances are actually kind of hitting on three key benefits. So one is around power efficiency. So these things have 10 to 100 times better power efficiency, which starts to allow us to do real-time intelligence at the edge. It also provides on-chip learning. And why is that important? Because that helps increase end user privacy. We're not going back to the cloud for everything. It's all happening on that chip on the device, right? So that helps improve enterprise security. And then low latency adaptive control, right? So this helps us optimize complex systems. So, if you're thinking about where can we use something like this, think about use cases where low power, security, highly adaptive algorithms are needed. And so we found use cases around automotive, infrastructure monitoring, smart products that are really powerful. I'll just give you one quick example that I think can bring it to life. Think about the automotive space. Power is absolutely at a premium in a vehicle. And so if we wanted to, for example, do voice recognition, pattern recognition for someone's voice imprint to open a car while the car is still off. So I walk up to my car and I want to unlock it with my voice. Neuromorphic computing is a great example. This is a great example for neuromorphic computing because I can walk up with the power being off essentially, or very low power usage without draining the battery, but you can use a neuromorphic chip then to do that voice recognition. So I could unlock my car without ever having to turn it on. Super powerful. All right, let's talk a little bit about robotics, which is one of my favorite topics. And I think there is a tremendous shift that we're seeing from, robots have been around for a very long time, right? But historically they've been in manufacturing settings, maybe in safety cages, doing their own thing. We are starting to see a paradigm shift to robots starting to interact more with humans, right? Collaborative robots, cobots, thinking about that human robot interaction, right? And then robot to robot interactions. And so I love this example that you're seeing on the video here. There's no audio, so don't worry if you're not hearing anything. It's just for you to see how these bionic ants by Festo are actually cooperating. So these are collaborative, cooperative, robotic ants that work together under a set of rules. So the ants have, 3D stereo cameras on their heads. So that helps them identify objects. It kind of contextualizes the environment around them. And they can communicate and coordinate with each other. And they can essentially coordinate their actions, their movements among each other, right? So if you think about what that's demonstrating, it's how autonomous individual components, robotic components, can solve a complex task together, working as an overall networked system. So, if you kind of abstract that away and maybe think about it for the factory of tomorrow, you can think about future production systems that might be based on intelligent components that can sort of adjust themselves flexibly to different production scenarios. And you're really taking that level of control up to a higher level now. And then, if we extend this concept to the broader workforce, and think about collaboration, collaborative systems, right? We all know how to do the human to human. We try to do the human to human collaboration, things like Zoom, et cetera, in-person interactions. We're starting to see, as I mentioned, that shift to human and robot interactions and collaborations, right? How do I understand what the robot's trying to do? And, how does it know what I'm trying to do? And then those robot to robot connections. But if you put that all together in a system and really start rethinking business processes, you can create some magic, right, across all those different means of collaboration. All right, so let's take a look at the next topic or the next area. This is actually one of my favorites. My degree was in materials science, and we are looking at doing research around smart materials. So this is really a class of advanced materials where the molecular structure is engineered to sense and react to stimuli in a predefined way. So the physical properties of this material can be altered in a predictable, in a repeatable, and ideally in a useful way in response to external conditions and signals. So, how do we do that? Right? Basically, we're thinking about using these materials that have sensors or actuators encoded at the molecular level. So some examples of that might be thermochromic pigments, right? They can change color at certain temperatures. Velostat pressure sensors, smart foam, hydrogels, shape memory elastomers, right? These are all different kinds of materials that you can really start to treat as sensors and actuators at the molecular level. And then we get into things like 4D printing. So I'm sure many of you have heard of 3D printing, right? That's definitely, been making a rise. But when we talk about 4D printing, it's really about printing the structure. So not just the object, but also the structure in a way that's designed to transform in a specific and pre-designed way based on different stimuli. So, I'd love to imagine the future where I know many of you have probably struggled with putting together maybe an IKEA chair, right? You buy it and then you got to follow the instructions and put this thing together. If you had a 4D printed chair, for example, it might come completely flat. Maybe you bust out your hair dryer or put it in your tub and it folds itself into a chair. And because it's been pre-designed in a certain way, and when you apply that stimuli, off it goes into its shape. So what are some of the potential advantages of smart materials? One, they're a seamless interface. If you, assuming many of you are at home, if you look around your environment, right, you probably have fabric on your chair, maybe fabric on your chair or somewhere in the room, the paint on your walls. Imagine that those could all be interactive, whether they're sensors or actuators, right, changing in response to what you're doing. It provides completely unobtrusive intelligence. I don't know if any of you have ever tried Levi actually had a jacket that had some smart thread embedded in it. You could start to control your audio device while maybe you're riding your bike, right? It becomes very unobtrusive because you're doing it just on your jacket sleeve. And also the other advantage these provide is to really create intelligence that is feasible at a much smaller and a much larger scale than what we have available today, right? I talked about all this happening at the molecular level, so you can get down really small, but also if you think about scale, think about pipelines, right? To really understand, if there's a leakage in a pipeline, you have to put a lot of sensors on that pipeline, right? Sensors are low cost, but there's still a cost to it. Imagine if you could just use a coating, right? That at the molecular level could then do that sensing for you. You don't need the same number of sensors, right? You can just do things at a much larger scale. So, we're looking at industries like automotive, fashion, I mentioned the jacket, safety and sports monitoring, healthcare, agriculture, think self-drilling seeds that know just the right time, moisture levels, et cetera, when to drill themselves down and plant themselves. And then some of those industrial examples, like I mentioned around the pipeline. This is one of my favorite topics. I think it's just really cool where things are going here. Oops. All right. So next slide. All right. And this one, actually the last speaker teed this up perfectly. I was going to talk a little bit about the metaverse and assume that some of you have probably heard about the metaverse. I love that shopping store example of, being immersed in an extended reality experience where you can go and look at a jacket and bring your partner in to check it out. But I'd also like to think about, how do we extend beyond that? How do we make this even more immersive? The ways in which we think about it, we have today visual, right? We have auditory experiences, right, from the headsets. But we haven't done much around haptics, around olfactory. If you think about your sense of smell, scent is an incredibly powerful trigger for memory recall, right? The olfactory system in humans is linked to the most primitive parts of our brain, which is a little different than all the other senses, right? It kind of goes directly to your amygdala and your hippocampus. And that's why, it's a reasonable explanation for why a smell can trigger such a detailed memory, right? Or an intense emotion. And just kind of another data point, right? We have 1,000 different types of smell receptors, but only 4 types of light sensors and about 4 types of receptors for touch. So we have 1,000 for smell, right? It's super powerful, but we don't use that in our immersive experiences. So we're looking at ways that we could extend that. Also thinking from the haptics standpoint. I mentioned going to take a look at a jacket, or you're in a shop. Could you actually smell the perfume, right? Could you walk over to a jacket and feel, how does the zipper work on this, right? And we're starting to see additional auxiliary devices that allow you through either ultrasound or perhaps a glove to be able to feel things at a fine grain level, right? And have that haptic control. So you can start to imagine training experiences, right? Consumer experiences where you're touching and feeling things, or, even being able to control a robot, maybe at a distance, right? Kind of that telerobotics concept that, you want the robot to turn a dial, you have to have really fine grained control and feeling over, like, how is that dial turning, right? And so that is some of what we're looking at, how to use those haptic experiences to extend and really immerse people as we move closer and closer to the metaverse. So I'm kind of taking the metaverse as table stakes, right? How do we go beyond that? And then I would be remiss if I didn't talk a little bit about artificial intelligence, right? And what we're doing to reimagine businesses, to reimagine interactions, people, right? And society itself. And I'll give some examples in each of these areas. But before I get into that, I want to talk a little bit about where we're going with AI, right? The opportunities around artificial intelligence are truly endless, right? This continues to be one of the most impactful technologies of our time. But we've been researching it for a long time, right? We've been working on it, and a lot of it is starting to be implemented. But when we think about it from a research perspective, where are we going next? Is we're trying to make it smarter, faster, better, right? More responsible. So when we think about the smarter side of it, right, the kind of the holy grail is the artificial general intelligence, right? Where are we trying to go? But we really have an idea that, we're not going to get to that full general intelligence, but we can in certain domains, right? If we think about it from an enterprise standpoint, we can get closer to reasoning, right? Where you're kind of going beyond explicitly foreseen or narrow circumstances. We can start to get into more of that reasoning if we look at it from an industry or a use case or kind of a more specific set of functions. And so we believe that that's where the future of smarter AI is heading, right? It's more around this enterprise artificial general intelligence and how do we get there? From making it faster, the speed of today's AI solutions are only limited by computational power at this point, right? So if you think about what platforms we have available, CPU is still going to play a big role. It's low cost, it's flexible, it's accessible. There's a wide set of development tools, frameworks, languages already built up. And that allows us to do faster development, right? Which allows us to be more adaptable, which allows us to experiment more, drive innovation. So that's still really important. But as Moore's law is approaching its peak, we are increasingly turning to hardware accelerators to provide the necessary compute power. So if you think about GPUs, the general purpose graphics processing units, FPGA, field programmable field gate arrays, these are new hardware accelerators that are starting to change the game, right? We've seen companies announcing new FPGA cards that are delivering 10 to 20 times improvement on throughput and latency as compared to CPUs, and doing it, back to that low power, and doing it at a lower power, right? So that's really important. And then on the other end of the spectrum, we're seeing new and emerging compute platforms like quantum, bio-optical compute that are they're emerging and have a huge opportunity to significantly change the game around AI. And then if we look at the better side, right, the more responsible, we really have to think from the beginning of how we're designing these, that we're designing for accountability, right? The governance that sits behind this. How do we plan for that? That we're thinking about fairness, anticipating and addressing bias in the system, transparency, making it interpretable, understandable, explainable. Honesty is really about trustworthiness. Can we trust these systems? Can we trust the data? Can we trust the models, et cetera? And then agency is, are we designing to be human-centric, right? Are we designing this to be sustainable, beneficial to society, right? When I think about it, I love AI and even robotics, kind of the physical instantiation of it. I love it because it can help humans to not to take away everything we do, not to take over jobs, but to take over the dull, dirty, dangerous work that people really shouldn't be doing, right? Let's put that into the intelligent systems. And then obviously, making sure that it's secure, right? I think that goes with the honesty and the trustworthiness. So let's talk a little bit, I mentioned how intelligence is going to help us reimagine business, people, society. So let's talk a little bit about each of those. When I think about how we're reimagining businesses, we're digitizing the world around us, right? And that provides a huge opportunity for increased intelligence at the edge. And it gives us the ability to start to create digital twins of everything, of products, people, systems, architectures, right? So that we can have better insights into the data that's coming off of those, right? So we understand activities, behaviors, and then we can turn around and use that to come back into design, right? And so the more we can understand a digital object, the more we can interact with it, the more we can understand how it's being used, and then that can filter back into new feature sets, how we, using intelligence to actually generate designs, right? The whole notion of generative design. Thinking about and understanding how a product is interacting or how an object is interacting with an ecosystem, right? And how does that change as it moves through a supply chain, for example, right? And we even call that the digital thread, right? Which is the platform that, across time and across businesses that really governs the digital representation of that smart product everywhere. And that's the digital thread that goes through it. And then you can start to use those creative tools to help generate and rethink what the products are that we're providing. So let me give you a real life example of how we're using that. Faurecia is an innovation partner of ours. They are a tier 1 automotive supplier. So they mainly do seating and interiors. And so, they're manufacturing seats, right? And we have actually started to create digital twins of those seats so that as it's going through the manufacturing production line, we can rapidly use computer vision to detect wrinkles or defects and get those fixed, help the human, not to do the fixes themselves, but to help the human accelerate that, or maybe help augment, right? If there are simple things that the robot could do it and the human does the final touch. But the more you can accelerate the production line, through insights, the faster things can go. But then we're also working with them to think through design tools, right? How do we create physical simulations of the interior? How do you create a configurable platform that starts to bring together the physical right? Which they are masters of. They've been doing this for a long time. They know how to stitch leather perfectly. But then how do you bring in the digital services on top of that? And how do you, look at the merging between the physical and digital services that you want to provide? And how do you design for that and configure for that? So those are some of the things that we're starting to explore with Faurecia to really help create, we call it the cockpit of the future, right? Where's the future of automotive going? When we think about the people side of it, we really need to think about how do we reimagine people and their experiences, right? How do we create the moments that matter, right? And really interact in the right ways. And so I'll give you an example that we're doing with Disney Studios. So, obviously Disney Studios is highly innovative, but we've partnered up with them to create the Disney Studio Lab. And it is a workspace to incubate innovation projects, right? And we are looking at ways to advance storytelling through emerging technology. And that could be, in the pre-production, it could be in how you experience it, it could be, in how the writers and designers and post-production all come together. But we're really looking at what is the future of entertainment. And so we've partnered with them in a few ways. One, to just stand up this physical lab, and you can see some of it here. You can see some of the rigs, and we've got drones, and we've got all kinds of cool stuff in the lab. But then we help them also shape, what does the innovation process and program look like across a set of partners? So it's not just Disney, it's not just Accenture. We have Microsoft in there, and HP and Verizon, Cisco. So how do we do innovation across the whole ecosystem? And then how do we really define, run, and create technology and experience pilots and solutions? And I'll just share one of my favorites. It's out in the public sphere, so I can talk about it. We're creating an interactive movie poster. And it started with a really kind of cheap and cheerful version where we did emotion recognition for the Dumbo release, the new Dumbo release on the red carpet. And someone could walk up and it would recognize an emotion. Are you sad? Are you happy? Are you angry? And then it would give you a video clip related to that, customized and tailored to that. And then since then, we've been evolving this platform to really start to understand and use intelligence to understand the intent and the context. If someone walks up and they're waving, are they waving hello? Are they waving to the friend? Are they waving goodbye? Understanding that context, and it's a simple example, and then being able to create a personalized experience around that. So look for an interactive movie poster coming soon to a theater near you, or maybe an Accenture Innovation Hub at least. But it actually has been used now in a couple recent movie productions, Black Widow and The Jungle Cruise. So it's out there, it's scaled, it's in the wild. And so the last little bit that I wanted to share was around how we're reimagining society, right? And I think when we think about all these technologies, at its core, if we are doing these to better society and help people, that technology and those solutions actually become powerful and useful for everyone. So a super quick example where we've worked with Charity Water. They're a nonprofit organization that provides clean and safe drinking water to people in developing nations. And they have, I worked actually in Ethiopia, where they have a set of hand water pumps that we've retrofitted with sensors and cloud connectivity, because if these pumps fail, that means the community doesn't have water until a local technician can get there and can do the repairs. So being able to understand, where these pumps are in their life cycle, and we don't have past data, right? They were retrofitted. So we use probabilistic programming to create a model of water consumption, using the data collected from those remote sensors. And then we were able to provide a systematic way to detect changes in that water consumption behavior. And then from there, capture anomalous pumps. So pumps that are different from the others, right? Pumps that are behaving differently. So essentially, we can start to determine, or can solve for an optimal policy that determines the best maintenance decision to be made on that asset at any point in time, right? So we're kind of taking the probability of when that pump is going to fail. So it's quite different than the prescriptive maintenance that we see today. So as we're making that shift, you could think about then, obviously this is for the good of communities and people, but you could think about, clearly how that could be applied, in factory or industrial settings to really start changing the game about how we think about maintenance. And with that, hopefully I have painted an exciting view of the future. I think after all that we've been through right over the last year and a half, and even prior to that, I really believe we are reaching a moment of truth. This is it's truly a moment where we're going to break from past mindsets. We're going to change our modes of living and working, and we're going to move forward to shape a world that will look and feel profoundly different from anything we've ever experienced. I think, I really hope all of you will embrace change as something that is to be passionately pursued, not passively feared. And I challenge all of you to become leaders who are masters of change, right? Who will welcome and help adopt all these new technologies and the change that's coming. And I hope all of you will help bring the future I described into focus even faster. So with that, thank you.
Super cool, Mary. Thank you very much. The crowd goes wild. Virtual applause. I know it's different online. Thank you so much for that inspiring presentation. I've also been taking pictures of the screen, sending it to my friends also who are just teasing them because they're in 3D printing and they're super proud of their printer. I stand to forget 3D printing. It's all about 4D printing. What are you doing? It's so 2020. So they're all going ballistic. And you did a good job when Martin says, for example, in the chat, Mary, comma, he's serious when he says Mary, comma, neuromorphic computing, robotic ants, cooperating 4D printing, material sensor, and actuators on a molecular level. Pause. Pretty cool. And then you did a great job if you're getting that in the chat. I also loved it. We don't have time for questions. We're going to want to respect also the time for the other speaker. But I think you really inspired us with everything that is going on. And the cool thing also, for not linking everything to what we're doing here today, but you were talking about the Dumbo poster, which can track your emotions. We have an AI cocktail maker in the VSF that can track your emotion and makes a cocktail based on that mood. So I love how this is already reality, like you said, and not just this distant future thing. I hope you enjoyed it. I hope you have you over in future OpenSlavas, because if I look at what people are saying, they're super excited. So same me, you probably noticed it. I was super inspired. So great.
Awesome.
Thank you
thanks
so
for
much.
having me.
There you go, and enjoy the rest of your day.